students, parents, families at home, welcome to the second Math Minutes with Mrs. Lewis. This one is all going to be about touch math. Touch math is a fabulous, fabulous strategy for adding, subtracting, and multiplying in math. It is a lifelong strategy. One of the best things about it is it helps kids get away from that problem of using their fingers. Okay, it's a lovely strategy because it lets them keep their pencil in hand. And a student with their pencil in their hand means that that student is engaged and ready to work. So that's lovely. When students drop their pencils, it's rolling under their desk, and that's where their brain goes. And we've had a drop in nice cognitive thinking. So touch math allows them to keep that pencil in their hand. It's a multi-sensory strategy, and that uses lots and lots of senses, and there is very, very little memorizing involved. So it is a fabulous strategy for kids that have had trouble learning their facts. Okay, so let's go. Every single number up to 9 has a dot code, and I'm just going to show you. 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. You don't have to know any other code patterns beyond 9, and later on you'll see why. And I remind the kids, or I tell the kids to note, your dots always start at the top of the flagpole, top of the number, and work their way down. This makes it easier for your brain to have that vision in a nice, organized manner. Okay? The dots also tend to be on corners and on roundabouts. And when we get up to the higher numbers, they're in chunks of 2. Okay? Some of your students have seen touch math where, for example, the number 6 might be 1, 2, 3, 4, 5, 6. I tell the kids not to do that because just double dotting is faster. Remember, our goal is to be efficient and accurate. So if just 2 quick dots is faster, that's the way we want to go, right? I'll tell the kids 4. If they end up with a math paper that has a triangular 4, no worry. Their brain knows that the pattern for 4 is this. It doesn't matter if it's written as a triangle, their pattern is more like the goalpost configuration, okay? With the number 7, we learn it 1, 2, 3, 4, 5, 6, 7 on the nose. Does 7 really have a nose? No. But by learning that verbal cue, 1, 2, 3, 4, 5, 6, 7 on the nose, it lets them know, hey, don't forget that outlier, and yeah, our 7 is like an outlier on our face. So again, you're trying to use all those senses to help these kids. What other people would call memorize, they're actually learning. 8, 1, 2, 3, 4, 5, 6, 7, 8, or they can go 1, 2, 3, 4, 5, 6, 7, 8. I discourage kids crisscrossing. It's unorganized and it's much more difficult for your brain to crisscross over. 9, I tell the kids again, you're starting at the top. 1, 2, 3, 4, 5, 6, 7, 8, 9. If you don't have that little face looking at you, you've missed something on your 9. So learning these is really important. And in the beginning, I'll call out a number random. I'll say 4, and I want them to go 1, 2, 3, 4 on their desktop using their fingers or pencil. Or I'll call out 8. 1, 2, 3, 4, 5, 6, 7, 8. Kids can do flashcard problems with this. They can actually touch point with their eyeballs. Okay? Eventually, kids will become fast enough that it doesn't have to be written large. They're actually tapping on their paper on a bigger number than what's actually shown there, but they're visualizing those points. So let's put it together and see how touch math works in adding. Okay? Let's take a problem like 8 plus 6. Okay? If I were doing that with my fingers, I would go 8, 9, 10, 11, 12. I would count up on the 6, right? Touch math the same way. Voice 8, 9, 10, 11, 12, 13, 14. And my answer is 14. Pretty quick. Okay? If I have a problem like 5 plus 9, it's faster if I use my voice on the big number. So I'll go 9, 10, 11, 12, 13, 14. It's always fast to voice your large number first. Okay? This is really good for number sense because it helps kids know that they can play with numbers. Just because it's written in this order doesn't mean that they can't manipulate and change those numbers in addition. Really important. And they can use this with larger numbers. If I add 358 plus 267, 8, 9, 10, 11, 12, 13, 14, 15, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4, 5, 6. When they're stacked like this, I tell the kids be careful choosing the larger number because you might get mixed up out of order. When you have a larger number stacked, I tend to have them go top to bottom. It keeps them more organized. Very quick, and I've seen kids just become incredibly fast at this. No fingers, pencil in hand. So touch math with addition, counting up. With subtraction, just like if we were to use our fingers, we're counting down. So 9 take away 4. 9, 8, 7, 6, 5. You hop to the other number and count down. Okay? If I had a number like 15, take away 7, okay? A single digit, I can still just count down. 15, 14, 13, 12, 11, 10, 9, 8. There's my answer. Again, I can use my touch math with subtraction with large numbers. I can take 482 minus 137. 2 take away 7, bigger on the bottom, I better borrow. 12, 11, 10, 9, 8, 7, 6, 5. 7, 6, 5, 4, 4, 3. There's my answer. Okay, so touch math with subtraction, I'm counting down, okay? With multiplication, how does this work? Now I'm going to use a combination of my skip counting and my touch math. So for example, if we had 7 times 2, we talked about earlier, that's a double, right? Okay, I'm not going to memorize 7 plus 7. I could go 7 plus 7, 7, 8, 9, 10, 11, 12, 13, 14. Or I can count by 2s on the 7. 2, 4, 6, 8, 10, 12, 14. There I'm using my touch math and counting by 2s on the 7. Okay? Same with times 3. What if I had 5 times 3? In this example, I can choose to count by 5s on the 3, 5, 10, 15. Or I can count by 3s on the 5, 3, 6, 9, 12, 15. Either way, I got 15 and that's my right answer, okay? Now, we talked about counting by 4s and I said, well, we're not going to memorize how to count by 4s because they're very close to the 3s. But what if I have a times 4? This is when I tell the kids you're going to count by 3s and then take another spin around. So, 3, 6, 9, 12, 15, 18, 19, 20, 21, 22, 23, 24. Okay? We don't do this until we're solid with our times 3s. So they're understanding that 6 times 4 is really 6 times 3 and then one more 6. Okay? Times 5, count by 5 on the other number, right? Okay, using your touch points. Later on we'll use our touch points and touch math with even larger numbers with multiplication. All right, so if we combine our touch math and the strategies that we used before, ultimately, here's what we end up with. We go back to our multiplication chart, and we actually have almost all of it filled in, except for 6 times 7 and 7 times 6, 7 times 8 and 8 times 7, and 6 and 8 and 8 and 6. That's it. So out of our whole multiplication chart, we've learned everything except for 6 facts or 3 turnarounds. Not bad, huh? Okay? And you would be amazed. I continue to be amazed every year when I see how fast kids get with their multiplication facts using touch math and their skip counting. It really, truly is phenomenal. I think that's it. Remember, if you have a question or you want to have this explained in another way, give me an email or have your student come find me, but we'll get together and we'll figure it out. Thanks.